So this is a question. We'll use similarity uh, theorems and proportionality theorems. For this, chapter 8, we have studied proportionality and theorems and similar right angle. So this question is based on similar right angle theorems. Okay. So as we see, this is a square with the side length AB. Each side length is 1, and PQRS are the midpoints. So we have to find the side length of the shaded square. Okay. So let this point be K. Okay. And this may be M. Okay. So now let us see triangle APD. APD, this triangle APD, and triangle KAD. Okay. So let's first prove that they are similar. Okay. So we know angle A is 90 degree because it is a square. So angle A is congruent to K, which is 90 degree. Okay, in the triangle KAD. Then we can take angle D. D here means, suppose this angle is X. Okay, so it's common in both the triangles. So by reflexive property, we can say that they are equal. So let angle A, D, and K is equal to is congruent to ADP. Okay, and that's equal to X by reflexive property. They are the same angles. Okay, and then in this triangle APD, if this is 90 degree, this is X, and we know some of the angles in a triangle is 180. So if this is 90, then P and D must equal to 90. So if D is X, then angle APD is equal to 90 minus X. Okay. And in the triangle AD, K, in triangle AKD, since K is 90 degree, D is X, so angle DAK would be 90 degree. Okay. So angle A is equal to K, angle D is equal to D, and angle P is equal to angle A. So these two triangles, triangle APD, or I can write here APD is similar to KAD. Okay. Now we can put this, I can show you by putting these triangles here like this. So this is angle A. Okay. which is 90 degree. This is K, which is 90 degree. D in both the triangles is X, which is equal. And this is P, which is 90 minus X. This is P and this is A. Okay. So we can make similarity statements like this. PA okay, PA is equal to PA here over AK, because in the similar triangles, the corresponding lengths are in the same proportion. So PA here over AK is equal to AD over KD is equal to PD over AD. So here, if we use this, we see that AD square is equal to KD times PD. Okay. So if suppose if each length here, I assume that is Y. Okay. AB is Y. Each length is Y. So AD is sorry, each length is 2Y. Okay. I let this be 2Y. Okay. Let AB is 2Y. So AD is also 2Y. So it becomes 4Y square. Then KD and PD we don't know. So to find PD, we can use this Pythagorean theorem. Okay. So AP is Y because it's the midpoint. So PD is equal to AP square plus AD square. So that is equal to AP is Y square plus 4Y square. So 5Y square is equal to PD square. So PD is equal to square root of 5 times Y. So here it would be square root of 5 times Y. Okay. So KD is equal to 4Y over under root P. Okay. Now we know that considering the triangles here, so now considering the triangles A, K, D, okay, and so considering a triangle AKD and S and D, we see that these are the parallel lines. So we can use proportionality theorem where the ratio of AS, ratio of S So the ratio of AD over DS, okay, will be same as the ratio of DK, because these are two parallel lines. This is 90 degree, this is 90 degree. So in a triangle, if there are two parallel lines, the ratio of AD over ST is equal to same as DK over MD. Okay. And this is AD over ST is like this is AD is twice of this. So DK is also twice of MD. Okay. But AS and ST are equal. So MK is equal to MD. Okay. So DK, as we found, was 4 pi over under root 5. Okay. So Km would be half of, okay. And what was y? Y is, it's the whole length AB is 2y, means y is half. Okay. So if it's MD will be half of KD. Okay. So it would be half of 4y under root 5. So it will be 2y over root 5. Now if we put y as half, so it will become 1 over root 5. Okay. And if we simplify, it will be 5 over, it will be root 5 over 5. So this is our length. Okay. Thank you.